All right. Hey, everybody. Welcome to All Things AI and Cloud here today. It's just me, Sebastian Maniak, will be the host. Mike will be joining us next week. He's at a conference. So today I'm going to dive into a couple, maybe three topics. One, prompting and specification engineering. Two, we're going to kind of go through a guide on how to set up Agent Gateway. And then also talk about some of the new things that are coming up and some of the blogs that we've been posting, and some of the content, especially around enterprise security that we're seeing pop up a lot, especially around kind of the agent gateway or really protecting our agents and applying AI agent authentication and identity in a production environment itself. But before we get started, please check out kind of solo.io for the new or AI agent in Kubernetes book. It's a great book by Christian and Lynn. Check it out when you have a chance. And we are still running our AI hackathon. So go to aihackathon.dev, sign up, cash prizes, some great expertise. We have a Discord channel for you to join, which is awesome, with a pretty huge community itself. From updates perspective, Istio Ambient 1.29 was released. Take a look at the notes itself. A lot of cool features that were added. We also have kagent version 0.8.0 dev is up in a release that kind of adds a lot of human in the loop, a lot of memory capabilities or session memory or context memory into the open source product, and adds the capability of you being able to include skills into your agents and deploy them faster. And of course, like we mentioned last week, Agent Gateway is going into the version 1.0 alpha. So everything's going to be kind of unified into a specific version, which is great to hear, as we'll have, starting with 1.0 and 1.0 alpha 2 to be able to kind of move forward. And we'll go through setting up an environment and kind of show you how you can get started with Agent Gateway itself. Also, from all the show notes, I'm going to be posting everything into our GitHub here, solo-io all things. So you can have examples of the code or anything that we are running itself. So the one thing I really wanted to talk about before I get into kind of some of the demos, and feel free if you have any comments, definitely jump in. Always welcome to have a chat. But I get a lot of questions about, hey, how do I write better prompts? And what I feel is when most people say, hey, write better prompts, they're just saying prompt engineering. And I feel that was a winning strategy in 2024, 2025, right? And it had a dominant workflow. You ask a chat, you get an answer, and then you iterate in real time, right? But as the models in ChatGPT 5.4 came out yesterday, it was leaked itself. Then you got Opus 4.5 and probably 4.7. Something's coming out shortly. But as the models become longer running and more autonomous, the bottleneck is starting to shift, right? You don't need to, or you don't get to babysit the session, right? You have to really encode oversight upfront for your agent. Yeah. And I've kind of been following other people, and I've come to this conclusion of these four disciplines of prompt engineering or prompting in 2026. One is the prompt craft, or the table stakes. And this is your classic prompting: clear instructions, examples, counter examples, providing guardrails. So what to do and what not to do when you're prompting. So have a long prompt, explicit output formats, how you want things to format, create rules for ambiguity. So if X conflict happens with Y, do Z, right? And this still matters. But we need to, when we are prompting or asking Claude Code or Codex to do something, we want to have those principles that have clear instructions. And this really then moves into kind of context engineering, where your your real leverage in the space, like your prompt might only be 200 tokens, but your context window is huge, 200K, a million size context windows. It means the prompt that you're giving it is a routing error. Make sure that prompt has depth in it, right? So when we're referring to context engineering, it's the work of designing the information or the environment the agent runs inside, be it system prompts, agent instructions, the tool definitions, the permissions, or RAG sources, docs and repos. I always post as much docs and repos, examples, URLs into the thing. And I want to give it a convention of how the org writes or how it builds. I wanted to know how it tests and ships as I'm defining in my prompt. I want to tell it how I want it to build, test, and ship my code, right? And this is how, if you see someone getting 10x more out of the same model, it's because they usually aren't better at words or wording itself. They're better at building that context infrastructure. So then the third step is this intent engineering, right? What agents should do. So we have, your plain clear instructions, what system prompts, what are the docs, how do you want memory to persist? But now then we can build this intent engineering and what the agent should do, right? The context tells the agent what to know, right? The intent tells the agent what to optimize for. This is where teams kind of break things into or break things at an enterprise scale now. We want speed versus quality. We want cost versus correctness, right? Customer satisfaction versus ticket closure time. There was something I saw on Reddit where somebody replaced their AI agent, or sorry, their customer service with AI agents. They were closing a lot of tickets, but the customer satisfaction was horrible, right? We want to know what, ship it versus false or fail safes it is, right? So we want to, if you don't really encode those trade-offs and escalation triggers, the agent will just pick a metric implicitly. It's just going to do whatever it wants to do. So we have to give it that intent and provide that understanding of what that agent should be doing itself. And this really leads to kind of let's say the fourth discipline is becoming specification engineers. So building out blueprints for autonomous work, right? Specs are what you write when you can't rely on real-time correction. Because as the code is building, you can't rely on it. It's too much. It's too fast. At this point, it's too fast. It's doing things faster than you could think of. So you have to give it a blueprint of what you want. And a good spec is, self-contained, structured, internally consistent, right? And we explicit about the quality that's measured in here. It's super important. So if your output keeps coming back at 80% correct, you don't have a prompt problem. You have a specific and evaluation problem. And what specific engineering means is that once an agent can run for hours, days, you can't rely on this live back and forth to fix mistakes, right? So from a specification engineer, this becomes a skill of writing agent executable blueprints, right? That are self-contained, so no hidden assumptions, undefined acronyms or missing obvious or context. It has to be, self-contained. It has to be verifiable. I want this done concept that has to be defined in checks and that someone can actually evaluate. I want constraints. There must be a must not, a preference, or that are explicit, right? Plus what should be escalated if something does happen. We want to have those constraints, and it has to be decomposable, right? The work must be broken down into chunks that can be executed and verified independently. So as you build those, you want to have that thing. So you want that broader implications, right? Your document now, is going to become your infrastructure, your strategy docs, your product docs, your run books, are going to start acting like specs that agents and humans can execute. So we need to be able to read them, right? Learning in Markdown and writing in Markdown is important, based really on those specifications. And what I have done, and I'll share this with you, I have put together like some of the templates that I use when I'm prompting and I'm building any type of use case. Let me post it in here so you could see. It's going to be in this repo. Let me just share my screen and you'll be able to see it. All right, perfect. So I have 3 simple templates that I use when I'm prompting my agents to do something, be it if it's OpenClaw, be if it's, let me just hide these bookmarks so you can see better, be if it's Claude Code or Codex. I'm building a self-contained spec or a general spec where I define objectives, what to do, why it matters, and who am I writing this for. I give it inputs, so links, documents, definitions, of what it needs, right? This authoritativeness. I give it delivery. What am I delivering? What is the outcome that I want to do? What is the accepted outcome that I want it to solve? What are my constraints? The musts, the must not, the preferences, escalate only if, it can't do something itself. And this is the workflow or this template that I like to build when prompting it. And I also, of course, want to have that workflow, like anti-graphic or anti-gravity is amazing for building out a plan and workflow. I still feed it this information because I want that proposed plan with checkpoints. I want to wait for confirmations. I want to execute, and I want to provide a final output of verification notes itself. And what other kind of templates I have here? If I'm doing code, I use a different template. So from a coding template, I have my repo, my build, my test commands, my conventions, what style, right? Link naming, all is identified. Change requests, non-goals. What are my constraints, right? What must not break when doing something? What are the security constraints? And of course, escalate if. My acceptance criteria for all these things, tests, added updates, commands that must pass, because you can ask ChatGPT and Claude to run a command, and there's a great chance that it's going to fail that because the commands do change. So you have to, know yourself what you're doing, have that manual validation step. Provide a rollout, right? What's backwards compatible? What are the migration steps for this itself? These are kind of the templates that I use when building any code or working with anything. And then if I'm doing any research, constraints. What are my time horizon? What time am I doing this research? When and where? What this happened? What must be the site primary resources? How is my output? A docs, a sheet, a spreadsheet. What are my deliverables? Right? Executive summary. What are my findings? What are my risk or unknowns? My recommendations, and what would make this wrong? And how can we verify quickly? All these things. This is how I'm prompting and I'm building my agents so they're more successful. So when I'm either building a PowerPoint to building a website to adding some code, I'm giving it as much information, not like a 1 or 2 liner. I'm like, here's the output, here's the outcome. Come back with me once you've hit these criteria and solved. And if there's something that I need to intervene with, then let me know, but only if there's something I want to intervene with. And this is where I feel like that specification engineers or these blueprints are going to come pretty popular and pretty big inside the next couple waves of everybody building agents and AIs and whatever we need to do. So yeah, check out that link of the templates I have. Feel free. You can always ask, Claude and ChatGPT and whatever to build the templates out. yourself. It's pretty quick. It's super simple, per se. So from that, the next topic I wanted to kind of move on into is one of Christian Posta's posts here. And I thought it's interesting, and it's, and even he says it, he's at the front of having those conversations with the largest enterprises and adopting AI, right? And when we deploy AI or AI agents in production, a real live agent that makes decisions or calling APIs or accessing data, we need to know who this is, right? And this is more important, I find, um, than models, and more important than building your prompts. It's really about identity. And how does anyone really know that agent is authorized to do what it's doing, right? Today, working through a post from Christian here, right? The title is Inbound Auth and Agent Core with Agent Gateway. Let me just post the link. It's on our solo website. And I find this is a fantastic post, and it makes sense because the title, one second, could be a mouthful, but don't worry. By the end, what we're going to do is identify a clear picture and talk about the three concrete problems to solve here itself. So to set the stage, right? Here's the setup. In this post, I'm just going to go in here. Christian sets up AWS as an AWS service that's called Agent Core, and it's part of the Bedrock suite, and it becomes a popular, and it's a very popular destination for deploying custom build AI agents at an enterprise scale. But when someone calls your agent a user, or another agent an orchestrator, Agent Core needs to answer two fundamental questions. Who are you? So authenticate the caller. And what are you allowed to do? Authorize the request. Agent Core gives you two built-in options for inbound authentication. The first is AWS IAM, right? Specifically the SIG v2 requesting signals. So if you're in AWS ecosystem, you know this, and caller signs their the caller sign their requests with AWS credentials, and it's the default. It's robust. AWS handles the verification. And that's one way of doing it. The second option is JWT, so JSON Web Tokens from an OIDC provider. And that could be anything from Cognito, Entra ID, Keycloak, Auth, Okta, whatever, right? The caller presents a bearer token, and Agent Core validates it against its configured discovery URL. And both these sound great, but there is an issue, and then there's a problem. And here's kind of the tension Christian identifies. IAM modes give you a strong AWS native cryptographical, verified caller authentication, but it doesn't tell you anything about the user on whose behalf that agent is acting. So the only way to pass user context is a header. So it's like a Bedrock Agent Core runtime header itself. And I think there it is right here. Christian talks about it, which is just it's just an opaque string. Anyone who's in that SIG v2 authenticated can set it to anything. There's no verification. And then when we look at the JWT mode, on the other hand, it gives you kind of that user identity. So the token carries the user's subject, issuer, roles, entitlements, but the built-in claim checks is basic, right? By the issuer and the audience. So maybe a client ID. So there's no native way to express an agent acting on behalf of a user, and there's no sophisticated policy engine behind it. So IAM gives you this strong agent auth, but no user identity. And JWT gives you user identity, but weak policy with no agent identity, right? Neither give you both. And this is the gap. And this is what Christian's talking about in this article. So he goes about and saying, well, this is where agent gateway comes in. This is where a true proxy is needed. And you put this in front of your agent core, the clients or other agents or your orchestrator, and they call agent gateway. It never exposes your agent core runtimes directly. So out of the box, it already buys you some valuable things. You can enforce sophisticated authentication policies written in Cell or Common Express language. You can also call out external policy engines like OPA, so Open Policy Agent, OpenFGA, I think even AWS verified permissions. And that's a significant step up from what Agent Core gives you natively now. But what's really interesting is what kind of Christian calls out here is on the on behalf of token exchange. And let me walk you through this setup because I think it's an elegant setup itself. Say you have a user, let's call them Alex, and Alex has a JWT token from their identity provider. And you have an agent. Let's say it's running Kubernetes with a service account identity. Agent Gateway can take both of those identities and exchange them into a single token. So in JOT specs, this is called an OBO token, right? On behalf of. And it looks like, really kind of looks like this, that the subject of the token is still Alex, the user, but the additional claims called the act for the actor, which contains an agent identity or a spiffy URI, right? A Kubernetes service account, itself, whatever. So why does that matter? Because you have a single crypto, a single verifiable token that tells you this agent authenticated with this identity and is acting on behalf of the user. And if the agent then call another agent, you can then chain that act claim, right? You can get a full audit trail of the entire delegation graph all in really one token, which is super neat. And Christian gives a great example is if a user named Christian might have a full access to GitHub, but the agent Claude, in his example, acts on behalf of Christian, might only get read-only access, right? The same user, different trust levels for the agent, fine-grained controls that wasn't possible before. And Christian kind of talks about also the three different patterns that we see here. So OBO token exchange, the first pattern is the purest expression of on behalf of approach. And the flow is really plain and simple. The user, let me just dive in here. The user authenticates with their IDP and sends a JOT to Agent Gateway. Agent Gateway takes that token plus the agent's own identity token and sends them both to a security token service and an STS, right? The STS then checks the policy. For example, does the user token include a may act claim, right? And that authorizes this particular agent. And if everything checks out, it issues an OBO token, so on behalf of token. Then step 4 is Agent Gateway forwards that OBO token to Agent Core as a bearer token. So Agent Core is in this JWT mode and validates it, then including that act claim. So when do you use this? Well, when you need to do end-to-end encryption or end-to-end cryptographic proof of an agent-user relationship, right? The downstream service, that the audit system, the agent itself, everything can be independently verified or can independently verify both identities from that single token. And really, this is kind of best for a high compliance environment itself. So pattern number 2, right? JOT pass-through with SIG v4. So this pattern is really a hybrid. Agent Gateway authenticates to Agent Core using SIG v2, an IAM model, but it also passes the user JOT tokens or the OBO on behalf of token as a custom header alongside the request. And you'll need to have an allow list, or you'll need to allow list that the header on the agent core runtime, right? So the agent code then receives that JOT in the header and is responsible for verifying it, right? Checking the signature, validating the claim, caching the JOT, and the agent has to, do some work here. And the big win is only agent gateway can reach agent core directly because of IAM policy enforcement. But if your agent still has a full JOT valid available for whatever fine-grained, decision it needs to make internally, right? Then you both get that hard perimeter and that rich context in here itself. So option 3 or pattern 3 is the simplest from an agent's perspective. Agent gateway validates the JOT token at the edge and extracts the claim. The user's sub, their roles, their entitlements, and then it calls agent core via SigV2 and injects those claims as a standard header, right? And it's also to note here, Christian is careful to note that the security model, that user ID header, is opaque to the runtime. It doesn't verify it cryptographically, right? The security guarantee is only agent gateway via an IAM policy scoped to the gateway's role, which is allowed to call agent core and set those headers. The trust lives in the access control layer, not in this token verification layer. So when would you use this pattern? Lightweight agents, agent frameworks that don't have native JOT verifications, or when you want to keep agent code as simple as possible. So if the gateway is already handling identity validation, why make the agent reinvent really what's happening itself? So definitely check this out. And if we step back and take a big picture of what kind of Christian wrote here, and the architectural insight beyond, just agent core, is that he's really describing a general problem in the agentic AI world. Most agents run are not built the same way. I'm just going to go to the top here. Most agents runtimes are not built with the same security rigor as enterprise API gateways, right? They make trade-offs. Agent core is actually ahead of many, which is great. It has IAM and JOT token modes. But for production workloads at scale, you need more, and we see customers asking for more. You need stronger caller authentication, stronger cryptographic user identity, agent identity, delegation chains for multi-agent flows, and policy informants that can handle ABAC and reback, and not just static claim checks. So the gateway pattern solves all of this, having that gateway. And the beauty is that agent gateway speaks HTTP, MCP, and A2A natively. So it works whether your callers are human or agents or an orchestration framework. And just one thing to mention or to flag from his post here that I think is really insightful is Christian mentions why API gateways won't cut it, or AWS API gateways won't cut it. Because they can validate JOTs, but they can't natively validate a JOT at the edge and then call an agent core backend with SigV4 and then inject verified user ID headers. And that combination requires really a more built-in or a more purpose-built agent, right? And that's kind of where Agent Gateway fills the gap in that space, which is great. So really, that's a wrap. I wanted to talk. That's a wrap for me talking about Christian's post because I found it very interesting, and I do have the link below. Feel free to check it out. But what I'm going to shift to next is setting up Agent Gateway in a lab or in your own environment, because I think it's important to understand the simplicity of building this out and how you can do this in your environment. So what I'm going to do is let me open up a command prompt in here and we'll jump in. I think this is good to see. Make it a little bit bigger. So in this segment, what we're going to do is we're going to dive into specific products and how to set them up. And throughout the weeks, throughout the episodes, we'll start with the basic setup and move to more advanced features, advanced deployments inside, or using all the solo products, or using even any AI or cloud product itself. So the first thing I'm going to do is I'm going to spin up a kind cluster. And everything I do in here is going to be in the show notes, so you're going to be able to see it. So let's do kind cluster, and I'm using kind. It's an easy way for me to test things. If I was doing this in an enterprise, if I had access to kind, I'd do it in there. If I had access to AKS, EKS, I'd jump in there. But in the end, I'd probably build the prompt and make my agent do the entire test for me and have the results. So first thing, we're going to build the kind cluster, and we're going to go through the getting started of Agent Gateway. We're going to install the Agent Gateway control plane and the Agent Gateway runtime in our cluster. So let's apply the CRDs, so the Kubernetes Gateway API CRDs, into my lab. Then I'm going to deploy the CRDs for Agent Gateway. So this is the control plane, and I'm going to be using Helm to make this happen. Once that's happened, I'm going to install the Agent Gateway control plane in this deployment. So let this just download. Always during the lab. Oh, there we go. And I'm going to install the Agent Gateway. So to make sure that Agent Gateway is running, let's just do clear kubectl, get pods name Agent Gateway system. Perfect. Our Agent Gateway is now up and running. Very simple, very easy. So the next thing that we need to do, once we have our Agent Gateway set up in our Kubernetes cluster, we need to create a gateway. And we're going to use the Agent Gateway class. Here, I'm just going to paste this example. So here I'm using the gateway class. I'm giving it a name. I'm going to run this on port 80 itself. Once this takes like a minute or two or a few minutes to run, let's just verify the deployment is working. So we'll do kubectl get gateway Agent Gateway proxy. That's what I named it. Namespace Agent Gateway system. Perfect. That's running. And I'll paste the next commands. I'll just get a deploy to see where we're at. Perfectly. We successfully deployed it. Let's see if we got an external IP. No, we haven't yet. So what I'm going to do is, let's just go up. In here, I'm just going to run cloud kind provider. Let that run in the back, and that will be my load balancer. Already assigned my IP. So if we run that again, perfect. There is my IP address for my LLM or for my proxy itself. I'm going to just get that external IP address, and I'm just going to put in a variable. So it's easy for me to test and call. And now that I have my gateway set up, the first thing I'm going to do is configure my LLM gateway. So my provider, I'm going to use OpenAI. I already have OpenAI inside my environment variables. So if you don't, do this. And the first thing I'm going to do is create a Kubernetes secret store. So I can store my API key inside my Kubernetes environment. If you have HashiCorp Vault, or if you're storing keys other ways, you can pull from that data. But for this example, I'm just going to store it in here. Once we've create the key, we have to create the backend. So we have to create the agent gateway backend resource to configure an LLM provider that we're going to reference with the API key. So I am going to just paste this and we could talk about it. Here's my agent gateway backend. I'm just going to call it OpenAI, and GPT 4.0 is the model I'm going to use itself. You can change the model, whatever you want in here. Now that I have the backend created, I need to create a route to the backend. So I want my agent gateway proxy to route to the backend of it. And there's a couple ways, and this is where you can add more things. But now I'm going to create my HTTP route for OpenAI, reference my proxy, and I'm just going to use a path prefix of /OpenAI. Perfect. So now for me to test this, fairly straightforward. I'm just going to use the curl command to test this pretty simply. So I'm curling my IP address. I'm going OpenAI, and here's my response. Very straight. And so now every connection that's hitting every agent, every user that is going to be talking to my LLM is now then proxied through Agent Gateway. And then this gives me the capability of introducing security and compliance and governance and observability on that. For example, I can now introduce prompt guards, right? Provide constant safety and PI protection to ensure that the prompt-based interactions with that specific language model are secure, are appropriate and aligned with intended use, right? And these mechanisms help filter, block, and monitor and control that LLM input and outputs to filter offensive content or prevent misuse or ensure ethical and responsible AI usage itself. So we'll set up a couple prompt guards on here. So for us to build prompt guards, what we do is we build agent gateway policies. And that's a resource for the prompt guard field to deny requests and provide, what's included. So for example, I'm going to apply a policy. So I'm going to build the prompt guard policy in here. And the backend, so AI prompt guard, request, response, reject due inappropriate content. That's the message. And if anything with a credit card information. So when I go back to, my prompt and I curl OpenAI, so I'm going to do a curl on OpenAI. Hey, give me some examples of MasterCard credit card numbers. Here it is, rejected due to inappropriate content. So I can build these prompt guards. I can start building these things. And I could, have an example of emails, phone numbers, social security numbers, Canadian social security numbers, whatever it is. And then we can send other stuff. Like say if I send another request, but this time I don't put credit in it because that prompt had credit card. I just put card number, right? I'll get a response, right? Saying, hey, can you give me an example of MasterCards? And if I make this into JQ to make it look nicer, let me go all the way to the, oops. So now I get a response. Hey, I'm sorry, but I can't provide you, real time and, fictitious credit card numbers itself, as an example. So what if we want to do other stuff? So we want to mask the credit card number. So let's apply a masking, right? So prompt guard, we have our built-in credit card, action is going to be masked, right? And then let's send another request. In here, so user, and hey, what type of number is this? It's just the credit card number. And we can see that the credit card number now is masked throughout our response. So giving us another, layer of protection inside this platform. Let's just delete that policy. And the last thing let's jump into is kind of enrichment prompts. So this is something specific, and we get a lot of customers asking, but prompts are basic building blocks for building an LLM or guiding the LLM to produce relevant and accurate kind of responses. By effectively managing both the system prompts, which set initial guidelines, and user prompts, which provide specific context, you can specifically enhance the quality and coherence of that model by having system prompts and user prompts itself. Because when we curl, just clear this. When we make a curl to our OpenAI, we can send, the user and the content, hey, parse this unstructured text into CSV format for me. So we're giving that content that it's going to parse this in CSV format. Perfect. But what happens if we don't put that in there, right? What happens if we refactor and improve the readability and management of that prompt by building, a system prompt, right? That content, parse the unstructured data. So in this example, I'm telling that the system always has to parse this data in CVS format. And if the user asks me for that request, I'm going to get that output in CVS format. And for us to be able to do this, append or append and prepend prompts, we once again build a policy around that. So I'm going to build an agent gateway policy for my HTTP route with my backend being prompt. I'm going to prepend. So I'm going to prepend that parse the unstructured data always in CSV format. And now if we send that same request, but without the structured system and content, we're getting the response in CSV file because that's the intent. That's what we appended or prepended the system to do itself. And then, of course, we can overwrite these settings levels. We can, let's say I have an example here of changing it. Hey, here's the system prompt in JSON. Now we're going to overwrite it. Now we're going to get the response in JSON. So you have that capability of overwriting the policy if you want, but you can also set guardrails not to overwrite that policy. So it's pretty straightforward and it's pretty quick and simple for me to build a policy, build an agent gateway to proxy my LLM connections and apply any type of guardrails that I want to inside of the platform. Just like we're doing with LLMs, we could do the same thing with MCP servers. We could deploy an MCP server in here, and we'll create a backend for this MCP server. And once we have the backend, of course, we need a route, just like we did with the LLM provider. So now we have a route created. And we can verify that this route is working. I'm simply just launching npx. And this will open up a new browser window. For us to be able to connect to itself. So all these guides, all these, the deployments, all these settings are available all on our website for you to check out. Let me share that 1 second here. Perfect. So anything from installing the agent gateway to setting up your LLMs to connecting your MCP servers is all on our website at agentgateway.dev itself. So I know we're coming at the top of the hour. I just wanted to mention again, one, thank you for joining me, right? Definitely like and subscribe. Next week, we'll have Michael back on. We'll be doing some more AI and cloud talk, giving you updates on what we're going to do at KubeCon, what are some new blogs that are being posted, the content that we're going to be building. And if you have any specific content that you want us to show on how to do things, how to set up Agent Core with Agent Gateway or Entra with Agent Gateway, or how to help you build better and quicker agents, feel free to comment on any of the socials that we're streaming live today. But with that, definitely check out solo.io for the Kubernetes book, and check out our AI hackathon, join, and of course, check out any of our open source projects like agentgateway.dev or kagent for more information. And we have Discord channels for all of them for the community that anybody can join and listen. Well, anyways, appreciate your time, and like and subscribe, and see you next week.